Well, we're back. You all should have just completed your test on Module 1. Module 1 was 4 chapters. It was the longest module as far as chapters that I have. The last module actually is only 1 chapter, as I told you before. This module consists of chapters 6 and 7, and there's a lot of information in these chapters. And this is actually the longest lecture I have as far as slides. Um, and it kind of builds on each other. So if you have problems with chapter 6, you're probably going to have problems with chapter 7. However, when we go to the next module, the information changes again. So now we're finally getting into managerial accounting. I've got 6 competencies that we need to cover for this chapter. First one is define various types of costs and explaining how they change in response to changes in sales volume. And 2 shouldn't say use various methods. We're only going to use one method to estimate the fixed and variable elements of a mixed cost. We're going to identify various methods, but we're only going to use the 2-point high-low method. Third, we're going to explain how fixed and variable costs and factors influence purchasing decisions. And 4, we're going to distinguish direct costs from indirect costs. And finally, 5, we're going to identify overhead costs and explain how they may be allocated to profit centers. And finally, 6, we're going to describe controllable, differential, relevant, and other costs at the end of this lecture. So the first thing we need to do is we need to talk about our primary costs. We've got fixed costs and variable costs. And fixed costs are things like rent. If we have a pest extermination contract, we're going to pay them monthly. Depreciation, interest. And they're constant. The book says in the short run, but really it's the long run. Over a period, a year's time or so, they're going to stay the same. You know, rent doesn't usually change monthly. It's going to change yearly, and we have yearly contracts. The other thing about fixed costs is they decrease per unit as sales increases. And what that means is that if we've got one guest that comes in our restaurant in a month and our rent's $1,000, it's $1,000 per guest. But if we can increase that to 100 guests, then it's $10 per guest. And if we increase that to 1,000 guests, then rent is going to be $1 per guest. So it decreases on a per unit basis as sales increase. It doesn't decrease, but we spread it out as we have more sales. Then we have discretionary fixed costs, and those are a type of fixed costs. And they're defined by not affecting establish it in the short run, not RUM, but they may have long run implications. And the examples I have down here are landscaping, pest extermination, and training. Landscaping is a great example. I always, whenever I see a restaurant owner outside mowing his yard or mowing the lawn in front of the restaurant, I know that they're in trouble. If they don't have enough money to cover the landscaper and have it professionally done, then they're starting to have problems. And you know, the other example is pest extermination. You could go ahead and cut pest extermination out for 2, 3, 4 months, and you may not have any problems. But once you have problems, you have big problems. And then we have variable costs, and they change proportionally with the volume of business. And examples of variable costs would be food costs as an example. And if we assume we have a 30% food cost, for every dollar that we sell, 30% of that sales covers our food. And food costs have a direct relationship. If we were to graph it, it would have a straight angled line on an XY graph, as food fixed cost would have a pure horizontal line. And there's examples of those two costs graphed in your text. And then we have step costs. And step costs, if we took a little snapshot of them, they look like a fixed cost. But what happens is they have incremental increases. And the example the textbook uses talks about a housekeeping supervisor. They say they can manage, I think it's 15 maids. So if we have a 16th maid come on, then we need to go ahead and hire another supervisor. And the same thing happens with management. You know, we may be able to manage $1 million operation with one front of house manager, but once it goes over $1 million, we may require another manager in the front of the house. And once that happens, that management line pops up by the salary. It doesn't gradually go up like a variable cost does. It steps up, as it says in the step costs. And then we have mixed costs, and they're a combination of fixed and variable costs. And it's really the most common type of cost. If you think about it, utilities, for example, are not a pure variable cost or a pure fixed cost. You can manage utilities like you guys do at your home. You can do the same thing in a restaurant. And what happens though is if the restaurant's closed, we still have to keep the coolers going, and we have to have the air conditioning going a little bit so that the equipment inside doesn't overheat. So we're going to have a fixed portion of our utilities. We could argue that labor is actually a mixed cost because you have to have a certain amount of staff just to open a restaurant. You've got to have a minimum amount of people there just to get the doors open and have the dining room ready and food ready and things like that. And then the last thing on this slide is the formula for total costs. And we have total costs equal fixed costs plus variable cost per unit times units. And that should look kind of familiar to you. Back in algebra, that's really a linear equation. So if we had y equals mx plus b, b would be the fixed cost, and mx would be the variable cost per unit times variable cost. So really that's just a linear equation. And the most common, let me rephrase that, the way that we're actually going to go ahead and calculate mixed costs and separate them to their fixed and variable components is by using the high-low two-point method. And it's the simplest way to do this. It takes a little bit of math, but anybody can do it anywhere. It's not like the other ones where we have a scatter diagram or regression analysis where we actually need to spend time plotting or doing an analysis with a computer like regression. Of course, regression analysis is going to be the most accurate, but I don't expect any of you all, when you leave here, to go into a restaurant or a hotel or some other type of hospitality operation and have the resources to do regression analysis. But if you remember how to do the high-low two-point method, all you need is a calculator and a pen and a piece of paper. You can get it done. So let's look at the high-low two-point method, and I've got a real simplified example. What we have is we've got sales and we've got units for 4 months. So what we do is we look for the high and the low on those 4 months. And of course the high is April with $14,000 in sales and 7,000 units. And the low is January with $10,000 of sales and 4,000 units. So we take the difference of our high and our low months and we get $4,000 and 3,000 units. One thing I want you to always remember is that we always have dollars over units as our, I guess, fraction, if you will. So it's 4,000 divided by 3,000, and the difference is $1.34 per unit, or the answer rather. So the variable cost of this example is $1.34 per unit. Now we need to go ahead and take the high month. The book will tell you to use the high month and the low month to check yourself. If we do it right in the high month, we don't need to do that. So we're going to actually take that formula that we just talked about, the total cost equals fixed cost plus variable cost per unit times units. And we're going to take our high month, which was $14,000 in total costs, and we're going to plug in the 1.34 for our variable cost per unit, and we're going to use the 7,000 units that we had in the high month in April, and we're going to solve for fixed costs. So when we do the math, we get $4,620 as our fixed cost. So our variable cost is $1.34 a unit, and our fixed cost is $4,620. And we can actually go ahead and now create a formula by plugging in the fixed cost that we found and the variable cost that we determined. And we have a cost formula where we can forecast costs. So its total cost equals $4,620 plus $1.34 times our number of units. Now what we can do is we can actually go ahead and forecast our costs based on our number of units. And the example I have here for you has 5,200 units, and we plug it into the formula, and we find out that if we have 5,200 guests or rooms, depending on what the units are, our cost for this example is $11,588. So a comprehensive example is where we're actually going to go ahead and look at our income statement and see if we can go ahead and develop a cost formula for all of our relevant costs. And This example is a restaurant example, and we've got meals sold of 2,000 and 8,000. So the low month is 2,000, the high month is 8,000. We don't have multiple months like we did in the last example. And then we've got 4 expense lines. We've got supplies, labor, utilities, and rent. So the first thing we need to do is we need to identify which costs are fixed, variable, and mixed. So the easiest way to do this is just to go ahead and take that dollars over unit. And when we do that for supplies, we get $2 a unit at 2,000 units sold. But when we have 8,000 units of sales, we have $1.375. So variable costs are defined as staying the same with various levels, volume levels, and this doesn't hold true to that. So it's a mixed cost. And then we have labor, and if you look at labor, labor is a variable cost. And if we take $9,000 and divide it by 2,000 units, we get $4.5 per unit. And at the high month, if we take $36,000 and divide it by 8,000 units, again we get $4.5 a unit. So that's a variable cost. And then utilities is another mixed cost, and when we do the math, we get 2 different dollars per unit at different volume levels. At 2,000 units, we get $2.25 per unit, and at 8,000 units, we get a little over $1 a unit. So we know that's a mixed cost. The mixed cost, we're going to have to go ahead and use the 2-point high-low method to separate into fixed and variable costs. And then finally, we have rent. And regardless of the volume levels, our rent's $9,000, so we know that's fixed. Okay, so the goal is to create the formula total cost equals fixed costs, or the cost formula, let's call it. I don't need to go through it again as we did in the last example, except for we're doing it with more cost lines. Okay, so the first thing we need to do is just go ahead and set up 2 columns next to our costs, one for fixed costs and one for variable costs. And if you remember, labor was a variable cost, so we just go ahead and write $4.5 under variable cost for labor. And rent was $9,000, and that was a fixed cost, so we're just going to go ahead and put the $9,000 under fixed costs. And the next thing we're going to do is we're going to separate the supplies and the utilities into fixed and variable costs, and then we're going to add all those costs together and create a formula. Okay. So, going back to supplies, we take our high month and our low month, or our high numbers and our low numbers, and we find the difference, and we get $7,000 over 6,000 units. It's always dollars per unit, so our variable cost is $1.17 a unit. Again, we're going to go ahead and plug our high month into the cost formula, and our high month's total cost was $11,000. And our fixed cost is what we're solving for. Our variable cost per unit was $1.17, and there were 8,000 units at the high month. So we do the math, and our fixed cost is 1,640 units. So now we plug those in as we did before on our columns for fixed cost and variable cost. We supplied the supplies, and now we're going to go to the utilities, and we're going to do the high-low 2-point method one more time. And we go through and we do the math again. We find the difference between our high month and low month of dollars and units. And the difference is 4,000 over 6,000, so it's $0.67 per unit. Students always ask, how far do we extend out the decimals? We're talking about dollars here, so we go to the cents. So you're just going to go ahead and forecast your variable cost to the closest penny per unit. And then we plug it into our cost formula. We do the math, and we find out that fixed costs are $3,140. So again, we go ahead and we add those to our columns for fixed costs and variable costs, and we add them up, and now we have our total fixed costs and our total variable costs for our operation, and we can go ahead and create the cost formula of total cost equals $13,780 plus $6.3 per unit times the number of units. And now we can project costs at different meal levels. So the example I gave you is assume we have 6,500 meals, and you plug that into your formula, and our total cost should be $54,990 at 6,500 meals. I'm going to warn you right now. you're going to do this once and you're going to think it's easy and you're not going to do it again, or hopefully you'll do it more than once. But if you don't, you're going to go into the test and you're going to be able to calculate your variable cost per unit, but you're not going to remember to plug it into your cost formula and calculate your fixed costs. So I encourage you to do multiple problems and do them over and over until it becomes repetitive for you before the test, or you're going to go ahead and go blank. And this will be a test question on the next test, or a test problem rather. Okay, so then we have fixed versus variable costs. There's a lot of situations where we can either purchase a fixed cost or do a variable arrangement. One example is rent. A lot of times you're going to pay a fixed rent of say $5,000, or you could pay, 5% of revenue. So what we need to do is we need to determine which one we would choose based on our sales projections. Would we choose the fixed cost, or would we choose a variable cost? And I have a formula down there at the bottom of this slide for indifference point, and that's the point where it really doesn't matter which we choose, because the fixed costs are going to equal the variable cost as far as our expense. So indifference equals fixed cost divided by variable cost percentage. So here's our example. Would we rather have monthly rent of $5,000 or 4% of sales? It really depends what our sales are, so we find out our indifference point of $125,000 in sales. And what that tells us is that if we project our sales to be exactly $125,000 for this period, we don't care which one we choose. However, if our sales are going to be less than $125, then we want the variable portion. And if you do the math, if you were to put $100,000 in there and you were to multiply it by 0.04, you get $4,000, and that's less than $5,000. We want to pay the least amount of expenses as possible. On the other side of that, if our sales are larger than $125,000, we want the fixed cost, because if we use the variable cost, our sales are going to be higher. So if we thought our sales were going to be $200,000 and we chose the variable cost percentage, then our rent's going to be $8,000 as opposed to $5,000. So it really determines what we project our sales to be on if we decide to have a fixed lease or a variable lease, or a fixed cost or a variable cost if we have the option. Okay, so now we need to look at more costs. We've got controllable costs, and those are the ones that we can manage. That means that there are non-controllable costs that we can't manage. And the non-controllable costs would be things like fixed costs. It doesn't matter how good of a manager you are, you can't change your rent from month to month, as an example. And then we have relevant costs, and those are costs that must be considered in the decision-making process. And we have irrelevant costs, which are up here, and they have no bearing on our decision-making process. And I'll give you a couple of examples, or an example. I was recently buying a car, or I needed to buy a car, and I was choosing between different types of vehicles. And the first thing I did is I went ahead and called my insurance company, and I told them about 2 or 3 different cars. And I found out that the insurance was going to be about the same no matter which vehicle I bought, because they're all about the same size, and they're all 4-wheel drive, and they all have V8s. So insurance was an irrelevant cost, because it was the same. The other thing that was an irrelevant cost was gas mileage. I was actually looking at a Toyota versus a Lexus as an example, and they were essentially the same vehicle. They just had a different badge on them, and their gas mileage was about the same. So I didn't consider gas mileage when I was buying my cars. Now, relevant costs would be the selling price. Maintenance, if it was a Toyota versus a Lexus, those might be different. So those are relevant costs. Sunk costs are past costs relating to a past decision. What my dad used to always say is there's no use crying over spilled milk. That's because the milk is already spilled. There's nothing we can do about it. It's a sunk cost. So assuming that the car that I bought, the engine blew, okay, I hope this doesn't happen, and I hope that it's just an example we're using in this class, but let's just say that the engine blew up on it, and now I have a decision to make. I can either buy a new engine, or I can buy a new vehicle. It doesn't really matter how much I paid for my vehicle because that's a sunk cost. My decision now has to do with what I'm going to do today to have reliable transportation tomorrow. And I'm looking at expenses that I'm going to have to incur today to make that decision. So the sunk costs are not relevant in the decision making process. And then we have opportunity costs, and that's the cost of the best foregone opportunity. The example I used to always use was Brett Favre, especially back when I was at Southern Miss, because if he wasn't playing football, he was going to be a high school football coach, and that's actually what he did last year. Is he was a high school football coach, but he did it for no salary. But if you think about a football coach's salary, it's I don't know $40,000 a year or so, and his last year playing for the Vikings, he made $15 million. So the cost of the best foregone opportunity for Brett Favre was that $40,000 as a high school football coach. And then we have examples. These are buy versus lease, or rent versus own, or repair versus buy new. It's just a decision-making process between two alternatives. And this is what the book would give you in problem 613. We have the cost of equipment of $20,000, and then we have semi-annual equipment rental. Semi-annual means 2 times a year. And then we have salvage value. Salvage value is when we sell the piece of equipment at the end of its life and we get money back. And then we have annual costs. And those annual costs go down. And of course, we have less costs when we lease than we do when we buy, because we don't have to repair it ourselves, and we don't have to pay interest on the purchase. It's all worked into the lease price. So, which costs are irrelevant? Well, the irrelevant costs are the costs that are the same regardless of our decision. So if we look at labor, it's the same buy versus lease. If we look at supplies, it's the same as $1,000 each month or each option. And then finally, utilities. So it doesn't matter if we buy the equipment or lease the equipment, those costs are going to be the same. We do not look at those in the decision-making process. You're going to have a problem like this on the test, and if you use those, it's going to cost you points. So let's hope that you guys first remember to remove those costs from the decision-making process. Okay, the second one is prepare a 5-year cost schedule. We're only going to buy it once, so we buy it for $20,000. Now our semi-annual equipment rental, like I said, is twice a year for 5 years, so it's 6,000 times 2 times 5. I'm actually going to sneak back. I think I might have done that wrong. Looks like I did. It's actually 3,000 times 2 times 5, which is going to get us 30,000. So the answer is right, but that 6,000 should be a 3,000. And when we do the math, 3,000 times 2 is 6,000, and then times 5 is 30,000. So the 2 is because it's semi-annual, and the 5 is for 5 years. Again, I told you salvage value is when we sell the equipment, so that's a positive number as opposed to a negative number. And then we have interest when we buy of $1,500 a year times 5 years, or $7,500. And repairs were $200 a year times 5 years, or $1,000. So when we look at how much it costs us to buy this piece of equipment, it's $27,500. And we look at how much it costs us to lease it, it's $30,000. So we'd want to buy it because it's a less expensive option for owning or using this equipment for 5 years. Okay, so that's the chapter. I guess maybe it wasn't quite as bad as I thought, and we'll start chapter 7 shortly.